plant environments are very different than other applications, though lighting creates very high-intensity cooling loads during the photo period. During the dark period, there is no cooling load, but humidity is still being introduced. The plants transpire varying amounts of moisture as the plants grow. Precise controlling the zone room conditions while these changes are occurring is a challenge. An indoor plant environment has many factors that need to work together to achieve this optimal environment. There are 4 main elements that must be in sync in order to provide this indoor environmental control. The main driver for plant growth is light energy, as it provides the energy to convert the carbon dioxide, water, and nutrients into organic compounds. The heat comes from the inefficiencies in generation of light by the lamp ballasts, which create heat that warms the space. Infrared light contains a tremendous amount of heating energy. All of this heat energy needs to be offset with cooling during the photo period, lights on, to maintain an optimal space temperature. Watering creates moist soils, surfaces, and in some indoor plant environments, trays and troughs that hold water. This water evaporates constantly. Additionally, plants transpire water vapor during photosynthesis. The evaporation and transpiration together are called evapotranspiration and increased humidity in the space. This humidity load needs to be offset with dehumidification. Even during the dark period in an indoor plant environment, there is still a good deal of evapotranspiration that must be addressed. The amount of evapotranspiration is proportional to the size of the plants and their leaf density. The process of transpiration occurs because the water vapor pressure in the plant foliage is higher than the surrounding air. This difference in vapor pressure is the driving force for the transpiration process and is called vapor pressure deficit, or VPD. The VPD has an optimal range for each stage of plant growth. Too low of a VPD slows transpiration and growth. Too high VPD creates issues where the plant cannot transport adequate water to the upper shoot and can stunt growth, or in extreme cases, damage the crop. Within an indoor plant environment, it is crucial that airflow is turbulent and well mixed. This avoids stratification that can cause unequal temperatures and areas of high humidity. Correct velocity ensures every plant is at the correct condition for optimal growth. Creating a perfect condition in an indoor grow environment can be challenging. Heating, cooling, and dehumidification loads change rapidly during the shift from dark to photo period and vice versa. The amounts of dehumidification and cooling requires shifts as the plant grows larger and have greater rates of transpiration. Environmental control units must be able to be flexible and accurate to maintain the perfect conditions. Only Desert Air's Grow Air units with VPD sync environmental control have the 4 dimensions of control to be perfectly matched with the loads in an indoor plant environment. Due to the high intensity of lighting required for controlled environmental agriculture, most indoor plants environments have a high cooling load when plants are smaller and very limited dehumidification required. As the plants grow and have more leaf area, the rate of transpiration increases. The water in the plant turns from liquid to vapor, cooling the plant, which in turn cools the room and offsets some of the heat load from the lights. 2 things happen. The overall cooling load decreases and the dehumidification load increases. The controls in the Grow Air unit with VPD sync commands the stages, airflow, and valve positions to provide full modulation of the refrigerant system. This provides the optimal temperature from the machine at all times to maintain both temperature and humidity. Through the use of full-sized, fully modulating hot gas reheat coils during the dark period, the Grow Air can provide air at not only a stable humidity, but at a perfect temperature. The Grow Air units with VPD Sync Command environmental control technology has standard fully modulating variable speed fan control. The airflow varies through the grow cycle and provides a shift in the unit's cooling and dehumidification ratios. The sensible heat ratio of an environmental control unit is a measure of how much cooling is taking place versus the dehumidification. The Grow Air unit with VPD Sync Command Environmental Control will modify the coil temperature to minimize the dehumidification. As plants become larger, the Grow Air will automatically and dynamically adjust the amount of dehumidification. Typical air conditioners and dehumidifiers cannot adjust this ratio without impacting the capacity. Since the sensible heat ratio for the machine is optimized, separate cooling and dehumidification equipment is unnecessary. The use of a fully integrated system will yield a significant increase in energy efficiency and reduce the overall installed cost. What will Grow Air with VPD Sync mean to the cultivator? Don't make the mistake thinking equipment made for air conditioning office buildings or dehumidifying your basement are going to get you the yield and quality to be competitive in the indoor agricultural market. You need purposeful, duty equipment that has been developed for critical indoor growing environment. VPD Sync Command Environmental Control achieves the following: adjust capacity to meet your growing room's cooling requirements. Adjust the amount of air delivered to your grow room to meet temperature and humidity requirements. Reduces or eliminates the overdrying of a room during the startup or early veg time period. Is able to maintain tight, steady state temperature and humidity conditions for the perfect grow.